Welcome to episode 59 of the Nutanix Weekly Podcast. I got two of my co-hosts here, Mr. Jirah Cox, who ran away as soon as I hit the record button. Hi, Jirah.
Hey, man. I like to keep it interesting. You were wondering if I was going to come back.
And Mr. Ben Rogers, how are you today, sir?
I will have to say, Harvey, my jaw dropped like yours did when you hit record. And he went there. I was like, wait a minute. Hold on. Come back, please.
Gotta go close the door. I'm a professional.
That's right.
Yeah, you did a good job. We were talking really quick before this about episode numbers, and I wanted to make sure I didn't forget the episode number. And Jirah made the comment that he was going to distract me in the first 5 seconds, and unknowingly did it. But I still got the number off.
And some people also need to hear things multiple times, Harvey. If someone was wondering what episode number this was, what would that answer be?
59.
There you go. Nailed it. Good job.
So, all right. Today's topic is full frame rate VDI video. Nutanix and NVIDIA A16 GPUs eliminate the jaggies. So that's fun. Jirah, let's start with, actually, we'll leave this one to Ben first. Ben, you'll take the first question of the day, sir. What is a jaggy?
A jaggy. I think back in my day, it would have been considered the robot dance. It's the, it's just not a good video experience. And sometimes it feels like the old cell phone days where you feel like you're missing part of the conversation. And so getting that eliminated is going to be pretty important. In my opinion, it's going to be specifically important as we move forward with video conferencing. I know remote work is kind of a buzz thing right now. Companies are trying to get us back in, but you're still going to have to, even in office, you're going to have to remote work with other colleagues in other buildings, in other cities and other countries, i.e. So getting, reliable video is going to be more important as we move forward as a society and as we, for business reasons also.
Very good.
So not a British sports car that the Germans looking to, take over the market from. Not that kind of jaggy.
I wondered if jaggy was even a term, man. I was embarrassed to even ask that, but I will. Is jaggy even a technical term?
I see it here in a technical blog.
It's in a technical blog. Yep.
There you go. Okay. It's been Googled, my friend.
It's Googleable.
But as we were, I know we like this to be fresh and kind of on the fly, but as we discussed very briefly before this, Harvey, you and I, this is kind of close to our heart because we actually had to do this at a facility together.
Absolutely.
And it was killer. It was cool, but it was with some caveats that I think are warranted to talk about today. So as we get into this, great technology works. But that, in my opinion, there are some things you have to pay attention to as you're implementing this.
Absolutely. So let's get into it, and I'm sure that will definitely come out as we discuss it. The blog post here is about NVIDIA's newest GPUs and what they can do for you. The topic today is around the A16 GPU. Which on NVIDIA's benchmarking tool can run and support 64 virtual desktops, which is like, wow.
Yeah.
We don't normally see that many out of a single GPU. So definitely want to look more into this particular one. But that one particular is 2 vCPUs and 1 gig for your framebuffer profiles per node. And they were able to use 2 A16 cards to scale up to 128. But they make the disclaimer there that you might want to make sure that you've got a high performance CPU before scaling to 128 desktops. So yeah. I'll pause there for a second because I said a whole lot of words, and I'm going to bring in our resident translator, Mr. Jirah Cox, to help translate that. Let's start with something easy. What is a GPU versus a CPU, and why do I need both?
Totally. So the CPU does all the general purpose thinking that runs all of the compute, like in this case, like the host itself, but also the virtual desktop, all the calculations in Excel, powers a lot of your input output, right? So like keyboard input, network bits, and so forth. The GPU is the graphics card specifically, so it makes things look prettier, renders graphics, does some video decoding. If you're playing games, it does lots of work for 3D rendering. And of course, even in today's day and age, there's also like AI ML workloads as well for like machine learning and computational parallel processing that can happen on the graphics card. But yeah, so you can add a GPU to really any desktop, right? Laptop, desktop, virtual desktop, to make things prettier, get better graphics, make certain kinds of operations run faster, run better, run more smoothly. So that's how it's always been that way since almost like the dawn of enterprise VDI, right? Like, last 10, 15 years, right? Is of course you can run regular VMs, but you'll get a better end user experience when you also can bolster the graphics portion of them, right, with a GPU in the host server.
So that's good. But you said a lot of words too. Why do I need both? Can I just have just CPU? Can I just have just GPU?
Can't have just GPU for a end user compute use case. At least I can't think of how you'd make that work.
No,
it'd be tough. Because without a CPU, right? That's just a GPU sitting on your desk, right? I mean, not enterprise grade, not terribly functional.
Right.
But yeah, CPU only would be valid if you don't have very strenuous requirements for end user experience, aesthetics, the fancier apps like Ben touched on, right? Like the video conferencing, video decoding. If people want to basically have a virtual desktop that is indistinguishable from a physical desktop, a real laptop, but you want the benefits of VDI, right? Rapid patching, backups, recovery, disaster recovery, even like loss prevention, or data containment. Then we need to talk about having a higher tier VDI experience, which can often, one key to that's going to be better graphics, right, through a GPU.
Right. Absolutely. So, in my experience with GPUs, every time we talk about them, it's always, well, which users do you want to have a GPU set up for? How many do you want to use? And it's always, the conversation has always been about a subset of the users that you have in a VDI type environment. And this brings up in the second paragraph really is about, now that there's no real scalability limitations, now that you can fit 64 people on a single GPU, now we don't necessarily have to exclude people.
Right.
So go ahead, Jirah. I was going to take it to you anyway, so you go ahead.
No, and that density, like with my background is just traditional virtualization design. It's always kind of thrown me for a loop how the density falls off a cliff historically when you have to add GPUs to your design, right? If you're talking 16 users per card, maybe 2 cards per node, 30 users per node is not very dense. These numbers definitely, made me take notice when I can get 64 users per card or up to, right? And then up to 120 users per node. That's a whole ton of users, right? That's actually really approaching, like we talked about a couple of episodes ago with AMD CPUs, right? I can fit, a comfortable enough amount of desktops on the node that I actually kind of quit packing users on from a risk standpoint, right? Like how many users do I want one unplanned hardware failure to really affect at once, right? 200, 300, that's probably too many users, right? So this removes GPU as a design constraint from a users per node kind of density standpoint.
Right.
And to your point, really democratizes it, right? Like gets it out to the masses that even these not really huge desktops, right? 2 vCPU and a 1 gig frame buffer. That's pretty almost like actually low end on a per desktop basis, right? That's just enough graphics horsepower to make Windows run a little bit faster, be a little bit prettier, make some of your apps that were going to hit that GPU, like video decoding or video conferencing, run a little faster. That's a very economical way to get into that.
Yeah, absolutely. So they talk a little bit about the results they got from the A16 GPUs in that second paragraph too, which they said yielded over a 30% improvement in frames per second and latency approaching 1/20th of a second, which that's a mouthful there, right? Ben, why don't you tell us a little bit about what they mean by frames per second and why that matters?
Well, I might be off on my numbers, but isn't 32 frames per second 100% video in that you're delivering high definition video? So if you look at the graph, before they added the GPU, you were lucky to get to 25 frames per second. So going back to the jiggy or whatever it was called, once you get into the 30, once you get to the 30% delivery range, you're almost at full video. So one of the things I also kind of wanted to throw into the conversation is, Harvey, you were talking about this used to be a very selective group. And
Right.
for me, that was definitely true. I had to get the surgeons and the trauma people on the GPU machines because they were doing, diagnostic quality. Going back to that time period, what I'm wondering is what was the frame rate, that I was having to deliver in a DICOM diagnostic environment. And so I know that before we got the GPUs, I had very little adoption in the surgery realm because the graphics was a limitation to my VDI environment. When we added those GPUs and we were not getting these kind of numbers, I remember we were lucky if we would get 8 users on a machine with a GPU. So we had to buy, 16 GPUs, 8 on each side. So for me to see these numbers, it's not that I don't believe them. I believe they were done in a lab, but I wonder how that's going to equate in the real world where you have different users within an organization using, different applications like a radiology application or in architecture CAD or, what's that 64 number going to look like when you get past the knowledge worker?
Yeah, so the big to do around that will always be around what you're using for your frame buffer profiles that they have listed here. For these, they're talking 1 gig. And for a lot of users, 1 gig might be what they need, right? All of that will depend on the resolution that they're using and how many monitors they're using the resolution on. And so if you're just trying to do, 1080p type resolution, that might get you where you need to be. But a lot of other display types or other, workloads potentially could be a whole lot more detailed than that kind of picture. And that's where we get into some of those other use cases, Ben, that you're bringing up, where you might want to go up on their profile and the amount of memory that's dedicated to them out of that GPU. And so really, if we're getting down to the brass tacks like that, we're saying that these A16 GPUs have 64 gigs of memory that you can divide out the way that you want. In particular, for this article, they talk about doing that for as many users as you can to max it out to get as dense as you can go. But to your point, yeah, we can get a lot more detail, get a lot better utilization out of, much bigger monitors or, much more detailed views than like a 1080p type of view. So yes, it will depend on the users. Yes, it will depend on the workload. But going from, the conversation around, oh yeah, we used to have GPUs and we were lucky to get 8 on there. And now we're talking about the possibility of 64.
Wow.
Man, that's still doing it.
Yeah, that's a big increase for sure.
Yeah, that's a huge increase.
And we were also talking about, the knowledge worker is becoming the power user, but and specifically, we were talking about Teams, video conferencing. Yes, we're getting the push to get back in the office, but
absolutely,
that still doesn't mean we won't have to communicate with colleagues that are outside of our environment.
Absolutely. And for those who end up watching this on YouTube, you'll see all 3 of our little faces moving around. That just is another illustration of, what we want to make sure is happening. And doing that in a VDI or virtual desktop type of environment is as important as, having that sit on a laptop right in front of you, because, a lot of people don't necessarily know laptops have carried GPUs for a pretty long time now. But that's always one-to-one, right? Because you only have one potential, one monitor, sometimes two monitors out of a laptop. And that's not a huge load for a GPU to carry, as opposed to something like this, where we're talking about potentially providing for 64 users per card. So definitely different use cases there, but, giving the customers, the end users, the workers, something that is a much more rich environment for them to work with and actually use, that they'll be a lot happier with.
Yeah.
Well, and as those to the point of the users' expectations and requirements keep growing, right? The way like this article
Yes.
calls out,
I haven't met a user who asked for less.
Right. I mean, every year, right? And to your point around laptops having GPUs, even standard like laptop CPUs now actually often are like merging with the GPU, and
Yes.
there's GPU capabilities bolted on there. So it really puts the onus on the enterprise to say we where possible, we need to be done designing GPU-less VDI, right? Because it's going to be a pretty dramatic step down in user experience compared to standard status quo, right? So like we have to up our game for what we're delivering to our end users. And the article calls out even Chrome, looks for a GPU by default when you run that, right? No matter wherever you run it, on a laptop, desktop, virtual desktop. So it becomes important because like traditional data center grade enterprise CPUs don't include that GPU capability, right? You add that separately where you need it, so you can't assume that it's there. And like EUC VDI always has been, right? It's always about what does it do for the business, not directly about like cost comparison per desktop. That's a rational like tethering kind of math to do around cost per virtual desktop, cost per physical desktop. But it's more like this is unlocking capabilities to say, I get all of the provisioning, disk recovery, agility, scalability, data loss prevention outcomes of a good EUC VDI environment. And now I also don't compromise on GPU either, is the right way to think about this.
Right.
Yeah.
And so kind of in the third paragraph, they talk more about the potential use cases and the different work profiles, which Ben, you've already, hit and addressed. So once again, sir, you are before your time.
Got out boom from the drummer in the group.
That's right. So, the other thing, Jirah, everything that you just talked through, it kind of made me feel like either I'm getting old or they're getting faster, because I remember when a 64 meg video card was like really good.
I mean, they could be getting faster and you're getting older. It could be both.
Yeah. And now we're talking 64 gig, which is kind of crazy.
It's ridiculous.
I know my crypto mining friends are going to be disappointed that all this technology is now coming out at the time that they're taking the mining capabilities away. So I'm sure some of them are looking at this going, man, why couldn't this have been out when we had the ability to mine it?
Right.
So true.
So, the next paragraph, we're talking through about prior to the ability to provision GPUs at scale, disaster recovery for these use cases traditionally needed to be very, very carefully thought out and planned with complicated workflows that impacted RPOs and RTOs. We'll throw you another one here, Ben. Alphabet soup. RPOs and RTOs. What are we talking about here?
RPOs, recovery point objective. How much data do you want to be able to recover? Is it 24 hours? Is it 12 hours? Is it 1 hour? So, what is your data loss? What data are you willing to let go of to be able to restore? RTO is recovery time objective, and that is how fast can you do this recovery? Because while you're recovering, you've impacted the business in some way, shape, or form. And that's why you have a business continuity plan to deal with that outage, and how do you run the business without being 100% on the technology side. where I think this is very fascinating, and this was one thing that we were kind of teeing up before we got the record button on, was this used to be very difficult in a DR situation because you had to have like for like. And the reason you had to have like for like is, in my environment dealing with neurosurgeons, they didn't accept outages. If they were in an OR and they needed to look at a scan, and the only way they could get to that scan was through a Citrix session, and they had any doubt in the quality of the scan, they would cancel the operation. That's how meticulous these doctors are. And so for me, it had to be wherever they landed, whether it be in the primary site or a DR site, or we're having an incident that's got its 100% DR, they've got to have the GPU there to work because they got to the point where they couldn't live without it. And so I love the density that we're getting on, because now, it's making it more cost effective on the ROI to get that deployed to a DR. There is one question that I had about this, and I'll put it out there. This could be my ignorance. It used to be, you couldn't fail. You wouldn't want to fail a user in that had a GPU to a session that didn't have a GPU. It sounds like that some of the capabilities might be there, or this has gotten easier. So this paragraph, I think I might have read a little bit more into it that's actually there. So I asked the question, is this getting as easy where if you have these GPUs and all these boxes, you can fail these users over? No problem. It doesn't matter. They'll land on a session and continue to move along like they would. And what would happen if they landed on a session that didn't have a GPU?
Yeah, so this is highlighting that in the past, it's been even with like for like clusters, GPUs on both sides, disaster recovery planning and activation has been a little bit more challenging because of the extra steps needed to say this VM had a GPU over there. I want it to have a GPU when it fails over here, make all that work. So this is highlighting that that the real win here, right, is that now GPUs for virtual machines on AHV are first-class citizens, right? So you can fail those over from a cluster to another cluster, pick up more GPUs and keep it out and running. So faster failover, less downtime for those most demanding customers, like you're highlighting, Ben. And then also, I'm pretty sure that you also can fail over from GPU to non-GPU if you wanted to have like a lower cost DR cluster as well, right? That's also perfectly valid. Lots of companies design their DR environment to not be 100%, right? To save some cost there and deliver good enough, but not identical performance to in a failover scenario.
Right. Yeah, and I think that's important to highlight too. Is that before with GPU, it was always you tried to strive to have like for like, and then you crossed your fingers and stood on your head and hoped that everything worked the way that it was supposed to. Now you can fail over, from a GPU enabled Nutanix cluster to one that doesn't have GPU. So you don't have to incur that additional cost like Jirah was just talking about. And have that additional complexity in your DR environment if you don't need it, right? There will be plenty of cases where you do still need it. Like in Ben's case, talking through a medical facility and potentially having, doctors and nurses need that kind of rich experience for being able to look at, scans, x-rays, things like that. You probably want them to be able to still do that, even if you're in a failover standpoint. But if that is, just for Jirah playing, Call of Duty, he's just going to have to wait.
And that's important. That's a critical use case for me.
It's critical to you, but it's not critical to the business.
I guess it depends on the business.
Well, yeah, I guess that's true.
How happy do we want to keep Jirah? Nutanix would do a lot to keep Jirah happy. He's a valued asset in the organization, let me tell you.
I was going a different direction. I was going to say Activision would consider it very important that I play Call of Duty.
Activision would consider it very important. I agree 100%. All right. At kind of the close of the article here, they lay out what testing systems they needed, how they tested, what they used. The big thing that I guess I want to bring out here is they're using the Nutanix NX 3000 series, and that's one. Jirah, remind me I believe right now the 3000 series is the one you want to go for if you're using GPU.
Totally. This one right here with the G in the model name. This one is the 3155G. That's the NX branded node that supports the thermals for the GPU. It's a 2U form factor, single node. So high airflow, high power budget, which you'll need both of those for running GPUs.
Got it. All right. Let's see. I think we made it here. Any closing thoughts, Mr. Rogers?
If I ever had to go back into the seat where I was managing this and, had to relive some of my old history, I think it would be a lot easier this time. We haven't discussed the licensing and all this because it's beyond the part of this program, the podcast. But I would hope that as they're making the technology piece of it easier, they would be also making the licensing piece of it, because that's a whole separate conversation. Fair to be mentioned, but when you go into this, licensing is one of the things you got to definitely pay attention to. Absolutely. No, I think it's great that, man, we're getting this technology condensed to the point that we can have 64 users, on a single GPU. That's incredible. For me at this point, man, I would want to start seeing this in real time and, throw a little curveball to it and see how it reacted. But good stuff, man. Definitely a difference in experience if you have one and if you don't have one. So if you have any doubt, or as we move into more of a video conferencing realm, I think this is going to become a necessity instead of something. It'll be a to have instead of I wish I would have had. Right.
Yep. Let me throw a question out there to you, Ben. As you think about that and put that hat on, and you look at the possibility of being able to support 128 users out of 2 GPUs and 1 node, is that something you would do?
Well, the numbers wouldn't take long. CNSA at the time I was there was right at about 500 users. And so you're talking, man, with 5 nodes, I could possibly be getting to that number, so that's pretty impressive. And one thing that I didn't mention is that GPUs make a difference just beyond the taxing apps like EMR or radiology. Absolutely. Or CAD. Our EMR, there were screens, especially like in the drug allergy screens where they were doing a lot of comparisons. GPUs make a difference in how fast the application can actually run. So, people don't like to hit click and see the spinning wheel. If right. You can get it in their face, this does address that in certain portions of other applications, like an EMR system.
Well, I said closing thoughts, and now I'm going to open it back up. Only because you hit on a point that I think is important too. That most people before would look at GPU and say, well, that's only for the people I want to have this very great rich user experience that are using these certain programs and things like that. And now that we talk more about getting that out to the other users and we talk about the performance of the GPU, one of the things that we didn't hit on at all is how much of a difference it makes to your CPU to have those things offloaded and have your GPU take care of that. So, Jirah, I'll pick on you. Can you speak to that a little bit, sir?
Not in more detail, but you're right. No, the adding the GPU does offload some thinking that the CPU would have to do normally, right? To do all that video rendering. So in aggregate, if adding the GPUs, you'd see CPU usage go down, which lets you, if your CPU constrained, get higher density, run more workloads.
Yes. So in a nutshell there, we're saying if you add GPUs, you're going to see better performance, even if from a user experience, they're only just seeing things look prettier on their screens.
Yep.
Well said.
Now, the cost of these things, I was looking at that earlier today. With 64 users on one of these boards, cost is not that bad. I think your ROI would come back quick. Whereas back in the day when we were having to do this to begin with, it was a lot to go in the boardroom and go, hey, I need to spend several $1,000s to take care of 8 users. That was a hard argument to get across.
Absolutely.
I remember I had to demo it and show, here's the difference of it without, and here's the difference of it with. And imagine you're at home at 2 or 3 o'clock in the morning trying to, evaluate whether you need to come out of your pajamas and get in your surgical clothes. That was a compelling argument. But now being able to go in and go, hey, 64 divided by 6-7 grand, the numbers become very, very a different conversation. And I don't think it would be as much of an argument as it was 3 or 4 years ago.
Yeah, absolutely. That's it's kind of akin to a TV that does twice the resolution and weighs half as much as that big brick you got sitting on your desk. So yeah, they're definitely making strides here. And I love to see it. Jirah, any closing thoughts there?
I mean, some people need to hear things several times until it really sinks in. Harvey, what episode number would you say this is?
59.
There you go. Way to go, man. This has been episode 59.
And you know what? It's gonna be that much more trouble I'm in if it's not 59 in some way, shape, or form. So it's gonna be 59.
If we're wrong, we're fully committed to it.
I am fully committed to it until I hear differently.
I had to mute myself because that was so funny, man. I started in the microphone on this.
Yep. We'll probably have Mr. Andy Whiteside back on the next one, and we'll have him chew me out on the air if it was not 59. So, all right.
Stay tuned.
What?
Listeners, stay tuned.
Yeah, nice. Same bat time, same bat channel. I'll call it a wrap. Thank you guys for jumping on with me and discussing this, and we will see you for the next one.
Awesome.
Thank you all. Thanks, everybody.
Thanks. Appreciate it.
Yep.